Following the enactment of lending obligation in Europe, a revolutionary alternative, which is creating a source of pectins from fish disposal, is introduced. By this, manufacturing costs in biotechnology industry also can be reduced. This report focuses on pectins that derive from proteolytic enzymes of discarded fish, namely grenadier, which is from its head and its skin and bones. Logistic equation is implemented in monitoring the growth of bacteria. The first objective of this report is to make a comparison between the results that obtained manually via logistic equation and via computer-aided approach. Second, to explain the results gained from logistic equation and computer-aided approach. And third, to illustrate the graph structure of experimental bioproductions resulting from logistic equations.
Now, I'll explain about mathematical formulation, which consists of three things: literature review on logistic equations, application in biological aspects, and brief explanation of the logistic equations. Firstly, for general literature review on logistic equation applies when a population's per capita growth rate gets smaller and smaller as population size approaches a maximum imposed by limited resources in the environment known as the carrying capacity, denoted with letter K. Secondly, logistic equation could be applied in bread and alcoholic beverages when yeast grown in a test tube produces a classic S-shaped curve. Thirdly, let me tell you about brief explanation of the logistic equation of our experiments, where the formula come from Vasquez et al. Research paper. Like you see here, we want to find four products, which is bacteria biomass as dry weight X, cell formation G, lactic acid production L, and acetic acid production A, all denoted as P in this formula, where P is the product of that four categories, T is the time of culture, PM is the maximum production, VP is the maximum production rate, while lambda P is the product's lag phase.
After a comparison, we found out that data from both manual approach and computer-aided approach are aligned. But we found out that data from computer-aided approach gave us more accurate data. This is because this approach gave up until 17 decimal places. After plotting using the data we obtained previously, we get two graphs. One is for skin grenadier and the second one is for head grenadier. The first phase of these graphs is called the lag phase. In this phase, there isn't a very steep slope, it's just starting to climb up. This is because the metabolite productions is low. And then, the second phase, it's called the log phase. This phase has the steepest slope, and it is because the metabolite productions are increasing, thus the population is increasing. And now we're on to the final phase, which is the stationary phase. In this phase, the slope, there's no slope. It's horizontal. It's like this. It is because the metabolite productions are maintained and the carrying capacity is reached.
To conclude, the logistic function can be a very good use for monitoring the growth of lactic acid bacteria on marine pectins derived from fish discards. It is also determined that Lactobacillus brevis generated more lactic acid and cells in the head grenadier than in the skin grenadier, whereas Lactobacillus brevis produced more biomass and acetic acid in the skin grenadier than in the head grenadier. Based on the result, we can see that logistic function produced close estimates of the actual values. We can also see that the data from the manual and the computer-aided approaches are aligned, but the data from the computer-aided are more accurate than the data from the manual approaches since it provides up to 17 decimal places. The resulting graph visualizes both the same type, which is sigmoid, and the graph of the skin grenadier and head grenadier shows increasing patterns and are represented by three phases, which is lag, logarithm, and stationary. Therefore, this marks the end of the presentation from Group F. Thank you very much.